Okay, so today we're going to talk about infinite limits. This is not to be confused with the value limits at infinity, two different concepts. Infinite limits are just simply a limit where f of x increases or decreases without bounds, approaches some value. This could be either considered positive or negative. Technically, the limit still does not exist because it's unbound behavior. That is not suddenly not true anymore from our previous lesson. We just want to talk about now how to actually call it either a positive or a negative infinity for this limit. Now, there are two different ways you can figure out whether it's positive or negative infinity. You can either graph the function, if you're allowed to use a calculator, and see whether we're approaching a positive infinity or a negative infinity, or plug in a number just a little bit to the left or the right, depending on which side you're coming from, see what you're going to work with. If you plug a number to the right of it and you get like a negative number, you know you're going to the negative infinity. And the key is to plug in a very close number. Approaching 3, don't plug in negative 7 because that's not helpful. Approaching 3, you should plug in like 2.9 or 3.1, stuff that's really closer from left or right hand sides. That'll give you the correct idea of which way you're going. The odds of plugging in like 3.1 and giving you positive, but it really should be negative infinity, are non-existent. That would mean you plugged in wrong somehow. So for example, if I want to evaluate the limit as x approaches negative 1 from the right hand side of 1 over x plus 1, well, we plug in our negative 1, and we get a 1 over 0. So we know the limit does not exist. The key is I want to know whether it's positive or negative infinity for this. So since we're approaching from the right, let's plug in negative 0.9. Because negative 0.9 is to the right of negative 1. Well, negative 0.9 plus 1 is a positive 0.1. 1 divided by 0.1 is a positive 10. Because there was always a positive number, this tells me we are approaching a positive infinity for this function from the right-hand side. Had there been a negative 10, this would tell me plugged in it's approaching a negative infinity. Again, the same thing could happen if you actually graph this. But again, if you're not allowed to get a graphing calculator, you don't want to simply guessing, well, I think it's positive, well, I think it's negative, I'll take a 50-50 shot. Straightforward, just plug in a number. Pretty easy. So the limit as x approaches 2 from the left. So when we're plugging in 2 for x, we do have 2 over 0, so again, it does not exist. The key is whether it's a positive or a negative infinity. Well, from the left-hand side, I want a number that's less than 2, so 1.9, for example, would be perfectly fine. So 1.9 minus 2 is negative 0.1. 1.9 divided by negative 0.1 is a negative 19. Because we're talking about a negative number, that means this limit is really negative infinity. It's really that straightforward. You just, like I said, plug in a number that's a little bit to the left or a little bit to the right of the value you want to work with. Now, be careful. Don't assume that you should always plug it in immediately like that, because if we plug in right now our negative 3, something interesting happens. We get 0 up top, and we get 0 on the bottom. Our indeterminate form, which tells us we need to factor. So don't forget, that rule still applies. All those different rules we talked about will still occur when you have an indeterminate form, which is why we always want to plug in first. We don't want to assume something is the way it is. So when we factor, the top is just x plus 3. We factor the bottom, we get x plus 3 and an x minus 2. Leaving 1 over x minus 2. Well, if I plug in negative 3 now, as you can see, you get negative 1/5. This isn't an infinite limit. So don't assume, just because it's talking about infinite limits, it has to be. Again, remember, on the AP Calc test, you'll be just told to evaluate a limit. You won't know whether it's an infinite limit, you won't know if it's an indeterminate limit, you won't know anything except for the fact that it's a limit. So you always want to start off with limits by plugging in the given number. Don't need to go crazy in any other direction. Just plug in the given number first and see what happens. If it gives you a number, or if it gives you a number over 0, you know it's very straightforward. If it's 0 over 0, that requires a little bit more effort, and you actually have to go through a little more of a process to get the answer. Okay? So I want you to go ahead and do this one on your own. Again, remember, if you have an infinite limit, you want to plug a number that's a little bit to the left, because it's 0 from the left, to see whether we're positive or negative infinity. So I will go ahead and pause the video while you work on that. Alright, so for this one, you plugged in 0, we get 1 over 0, which means we have a does not exist case. So the key is whether it's positive or negative infinity. So from the left-hand side, I plug in negative 0.1, for example. 1 plus 1 over negative 0.1 becomes 1 minus 10, which is negative 9, because it's a negative number. That's why it's approaching negative infinity. Okay, very straightforward. For this one right here, we have to be careful, because we need to work with cosecant. So I need to rewrite this right here. Remember, cosecant is 1 over sine. Well, that means this right here is equivalent to the square root of x divided by another fraction. I can't plug that in yet. I need to actually work with this. So, when I'm dividing fraction, remember it's multiplying by the reciprocal. So when I have the square root of x divided by 1 over sine x, this becomes the square root of x times sine of x. So I now have the square root of pi times the sine of pi, which is square root of pi times 0, which is just simply 0. The reason why I went through that process is because if you worked with it just as cosecant, since cosecant is 1 over sine, we'd have 1 over 0, which is infinity. And we can't divide by infinity. It doesn't make any sense. We will talk about ways, generally for the most part though, if you are dividing by infinity, it generally is actually going to be 0. Again, remember, dividing by a fraction is the same as multiplying by the reciprocal, so essentially the 0 flips spots, which is why it works. We're going to deal with the whole dividing by infinity thing a little bit more in the next section. But always remember the different ways to manipulate the problem. Again, algebra manipulation, that's all that it came down to with this particular problem. Okay, so that's how you deal with the positive or negative infinity. It's, again, you're just using your limit rules, plug a number to the left or to the right to figure out which one it's going to be. Alright, so next time we're talking about when x is approaching infinity, positive or negative, how to handle that kind of problem. So I will see you next time.